As you know that I have discussed a number of homework problems together with the video lectures. Now I'm going to discuss the additional problems and hopefully you'd be able to understand them. I'll begin with problem number 2.16. So it's coming from Brown Lemay Burston book, 12th edition. In this problem, 4 different oil droplets have been studied. So A, B, C, D, that's how you label them. And the charges are given 1.60 times 10 to the negative 19. That's the first one. The second one, if you look at these numbers, is 3.15. So that's about 2 times. So just to save our time, rather than writing down the value, which is 3.15 times 10 to the negative 19, I would say it would be about 2 times the value of an A oil droplet. C is 4.81 times 10 to the negative 19, which is about 3 times that of the value of A. And D is about 4 times the value of the charge for A. So obviously the minimum number or charge is residing on A, oil droplet A, which is 1.60 times 10 to the negative 19. The question is, what is the significance of this, of the fact that different droplets carry different amount of charges? It's not only different, it's like 2 times, 3 times, 4 times that of one of the oil droplets, which is A. So this can only be explained if I assume that droplet A had 1 electron charge, so 1 electron sitting on it. Oil droplet 2 had 2 electrons. Oil droplet 3 had 3 electrons. And oil droplet D had 4 electrons. Now, let me explain to you, since these are experimental quantities, they're not exactly 2 times or 3 times or 4 times larger than that of A. So you know that, but it's pretty close to 2 times, 3 times, or 4 times, suggesting that oil droplet B had 2 electrons sitting on it, C had 3 electrons sitting on it, and D had 4 electrons sitting on it. So obviously that tells us the charge of an electron is going to be 1.60 times 10 to the negative 19 coulomb. So the unit is coulomb. Now I'm going to do number 17. Now number 17 has a number of parts to it, A, B, and C. The radius of an atom of gold is about 1.35 angstrom. So let me write down here 2.17. So the radius, let me explain to you. If this is the gold, this is the radius from center to the surface of the circle, and that value is 1.35 angstrom. So radius is 1.35 angstrom. So they're saying that express the distance in nanometers and picometers. So I'm just going to do your nanometer, and I hope that you'd be able to do the conversion to picometer. Pico is 10 to the negative 12. So let me show you how to change from angstrom to nanometer. In book, you'd find some of the conversions, like from angstrom to meter you find, from meter to nanometer you find. So I'm just going to use the values that we already know. So times, I'm not changing it, 1 angstrom, and that's 10 to the negative 10 meter. So I can cancel out angstrom and angstrom. Then from meter, I can get nanometer. So 1 nano, I think it this way. Nano means 10 to the negative 9. So 1 nano, I would write down as 10 to the negative 9 meter. So it should be read like this. Nanometer. That's what you have on the top. Now this gives you, let's double check these numbers. I think it looks all right. We get 0.135. So 0.135 nanometer. Okay, now in part B, they're asking how many gold atoms would have to be lined up to span 1.0 millimeter. So basically, now this is A, B, so what they're saying is I have a distance of say 1.0 millimeter. Let me show you. So this is the distance. And how many of those gold atoms can fit in that within that distance. Now, I'm going to explain that to you by drawing a picture. Let's magnify the atom so that I can better show you. Say I'm showing you 2 gold atoms. Now, if I have 2 gold atoms touching each other, so what's the distance does it span? This is distance, this is the distance. So it's not the radius, it's the diameter of each gold that I need to use. So diameter is given by 2 times the radius. So let's write down as diameter equals to 2 times our value. And you probably know already from math. So 2 times 0.135, 0.135 equals to 0.270 nanometer. So each gold atom is going to span 0.270 nanometer of distance. Now we're talking about 1.0 millimeter. So how many such gold atom you can put side by side? So let me show you in dimensional analysis method, starting with 1.0 millimeter times, now first we need to change millimeter to meter because I don't remember. I mean that I'm just pretending that I don't remember the conversion, and book would give me millimeter to meter conversion. So millimeter on the bottom, millimeter is on the bottom, and again I'm going to read milli is 10 to the negative 3. So 1 millimeter is 10 to the negative 3 because milli is 10 to the negative 3. Let me double check this. The top number is millimeter, 10 to the negative 3 meter. So that way you're not going to write down 10 to the negative 3 at the bottom, which is a very common mistake in this kind of problems. Now we need to get nanometer because the other value is in nanometers. So what I'm going to do next should be multiply this, and you can see that millimeter cancel out. So meter on the bottom and nanometer on the top. Again, nanometer should read like this. 10 to the negative 9 is nano. So that's 10 to the negative 9 meter. That makes a nanometer. And now I can use this value 0.270. So 0.270 nanometer is the distance spanned by single gold atom. So atom, gold. So now you can do this calculation and you get 3.70 times 10 to the power 6. 10 to the power 6 atoms of gold. So this is my answer. Now part C is asking that if the atom is assumed to be sphere, what is the volume of a single gold atom? I'm writing down on the top because I ran out of space here. So this part C, I'm just giving you the formula. The volume would be given by 4 by 3 pi r cubed. And we already know the r value, which is the radius. So pay attention to the unit depending upon what unit you want to get at the end. Now we are going to do problem 2.45C. So let's write down 2.45, chapter 2, number 45C. Question is, how many hydrogen atoms are there in each of the following? So they gave you ammonium phosphate. So NH4, 3, and then you have pure 4. So in this compound, there are 3 NH4 groups. So basically, you have 4 hydrogen per NH4, and you have 3 of them, and that's why it's 12. So 4 times 3 is 12. So answer to this question is 12 hydrogen atoms present. So that should be fairly simple. The next problem I'd like to go over is number 49. And again, I'm going to pick only a part of that problem to explain to you how to do this kind of problems. So 2.49, a part that I'm selecting would be cobalt 3 plus. Cobalt 3 plus. And they gave you the mass number is 59, which is protons plus neutrons. Now, by looking at periodic table, you can find out number of protons or atomic number for cobalt, and which is 27. So I got that number from periodic table. So let's write down that 27 coming from periodic table. That's number of protons. So let's write down P. Top number is protons plus neutrons. So by subtracting the bottom number from the top, I get number of neutrons. So let's write down these figures. Number of proton is 27. Number of neutron would be 59 minus 27, and that gives 32. And then this is not a neutral this is not a neutral element. In a neutral element, proton would be same as electron. Let's first think in terms of neutral. If this were a neutral cobalt, that means if it didn't have a 3 plus, then I must have same number of proton as electrons. It'd be 27 electron. But I know that it's not neutral. It has 3 plus. Each time you remove an electron, which is a negative charge, you create one positive. So how many electrons you have moved? 3 electrons. So by taking away 3 electrons, you get plus 3. And that means answer to this question is 24 electrons. So 27 protons, 32 neutrons, and 24 electrons. The next problem that I would like to go over would be 2.55. Again, and I'm going to pick only one of these problems, which is C, 55C. Predict the chemical formula for the ionic compound formed by Al3 plus, and so let's write down first Al3 plus. You need to combine that with CH3 COO minus. This is acetate ion. It's basically when you have acetic acid and you remove one hydrogen, then you get this ion. So we are going to combine these two together. Now keep in mind that minus is on the whole thing, CH3CO minus, so that's -1. What we're going to do next is move the charge. Let me show you. Forget about positive and negative charges, but just play with the number. That 3 comes to the bottom of the other, and 1 goes to the bottom of aluminum. So this gives you Al1, and we don't write down 1, so just Al itself means 1, then CH3 COO, and then I would have 3 here. Let's double check. 3 came from the top of aluminum, and 1 underneath aluminum came from the top of CH3COO. So this gives the final chemical formula of aluminum acetate. Now we're going to discuss 2.68 and part E as a sample. The question is, give the chemical formula for each of the following ionic compounds. So the E is for cobalt 2. So let's write down here so that I can explain to you. Cobalt in parentheses 2, hydrogen carbonate. Hydrogen carbonate. Now that 2 in parentheses means cobalt has +2. So let's write down cobalt 2 plus. Now I need to know the negative charge on hydrogen carbonate. So the question is, how do I do that? Think about the acid that has carbonate. And we know the acid that has carbonate is H2CO3. That's carbonic acid. If I get rid of one hydrogen from carbonic acid, I end up with HCO3 minus. And that's hydrogen carbonate or bicarbonate. Bi means single hydrogen. So now I'm going to combine HCO3 minus with cobalt 2 plus and see what formula I get. So now you'd have HCO3, this whole thing would be minus. Minus means -1. So now, just like before, we're now going to write down the formula. The top number goes to the bottom of the other. So that goes to the bottom of this. 1 goes to the bottom of this. And our formula is now cobalt 1, that's cobalt. And HCO3, I have more than 1, that's why I need parentheses. HCO3 2. Make sure you double check this so that we haven't made any mistake here. So this is the formula of cobalt 2 hydrogen carbonate. Now we're going to discuss problem 75. This is a question on organic chemistry. So let's write down 2.75. Part A, what is the hydrocarbon? This is the compound, organic compound made up of carbon and hydrogen. So that's hydrocarbon. Now part B. So we're going to do part B. Butane is the alkane with a chain of 4 carbon atoms. So they're saying that butane is the alkane with the chain of 4 carbon atoms. So let's write down 4 carbon atoms. 1, 2, 3, 4. And make sure you know some of these simple alkanes. 1 carbon is methane, then 2 is ethane, then butane, 3 is propane, and 4 is butane, 5 is pentane, 6 is hexane. So that's how it goes. So methane, ethane, propane, butane, pentane, hexane, that's how it goes. Okay, now we wrote down 4 carbon back to back. That's butane. And they're saying that write down a structural formula for the compound and determine its molecular and empirical formula. Keep something in mind. If it's a neutral compound, which in this case is a neutral, otherwise they would say positive or negative ion, each carbon must have 4 bonds. And hydrogen can only have 1 bond or 1 pair of electrons. So let's now fill in each carbon with hydrogen so that carbon gets 4 bonds. 1, 2, 3. Now this carbon, next carbon can get only 2 hydrogen because it has already 2 other bonds with carbon. So always make sure you pay attention to the total number of bonds. So I can quickly write down Lewis's structure of organic compound just knowing the fact that carbon would like to have 4 bonds, hydrogen would have only 1 bond. So this is now the structure of butane. Now let's write down molecular formula of that. Molecular formula, let's write down here using a different color. So molecular formula is C4H10. Now I can get empirical formula Remember the empirical formula definition, which gives you the minimum ratio of atoms in a formula. So 4 and 10, I can reduce it by dividing each of this number by 2. So I can get C2H5. It cannot be reduced any further, considering the fact I must keep integer. So we cannot have a fraction. So you can double check this. If you multiply empirical formula by 2, you're going to get back molecular formula. And molecular formula has to be a multiple of empirical formula. It has to be 1, 2, 3, one of those multiples. Now I'm going to go over number 90. So chapter 2, number 90. Now gallium consists of 2 isotopes. Of their masses are given 68.926 and 70.925 AMU, which is atomic mass unit. Now question is how many protons and neutrons are in the nucleus of each isotope, and write down the complete atomic symbol for each, showing the atomic number and mass number. Now 68.926, so we can round it off to 69. So we can write down 68.926. That's around 69. And the other one is 70.925, and that could be rounded off to 71. So I can now write down there are 2 gallium, 31, 69 at the mass, and second gallium 31, that number has to remain 31, 71. So these are the 2 isotopes of gallium involved. So we're done with part A. Let me double check. This is number 90. Yes, so we're done with part A. Let's work on part B. they gave the average mass, which is 69.72. So average mass of gallium, which is average over all isotopes of gallium, which is 69.72. And that equals to percent abundance of isotope 1 minus percent abundance, plus the percent abundance, of course, the times the mass of isotopes. Let me first write down the formula so that we all know. So P1 M1, this is percent divided by 100 plus second isotope, this is M1 for isotope 1, this is isotope 2, M2 by 100. So we got in terms of fraction. Now, I can keep in mind there are only two isotopes in this particular case. If one is P1, P2 is going to be 100 minus P1. Think it this way. If you have two different types of candies, if you have 50% of one of them, the other one would be the other 50%. How do I get it? 100 minus 50. So same is the case. If I know that percent of one is P1, the other one has to be 100 minus P1, and they're saying that there are only two isotopes of gallium. Okay, with that in mind, now I can use these values and solve P1. Now instead of P1, you can also consider it to be X. I think a lot of students feel more comfortable that way. Let's use X in our more familiar unknown. So X over 100, don't forget X represents percent of isotope 1. And the other one is going to be 100 minus X by 100 times mass of isotope 2. Okay, let's now label them. Mass of isotope 1 is 68 so let's write down M1, and 70.92, we're going to call it M2. So let's now put down all the numbers, and then I'm assuming that you'd be able to do the rest. X over 100 times M1 is 68.926 plus 100 minus X over 100 times 70.925. Now multiply both sides by 100 and then bring all the X quantities on one side and numbers on the other side, and then solve for X. So I don't have any more space here, but make sure you try yourself and solve this problem. All these questions and their solutions are also uploaded in Angel, but before you look at that solution, make sure you do it yourself and get an answer, and then you can compare your value with the value that you can get in solution book. In case you could not solve problem number 90, chapter 2, I wanted to show you the algebra. So this is continuation of what we had in previous page. This will be 2.90 from previous page, continued. So I'm going to show you the algebra part here. So let me first rewrite what we had. 69.72, it was on the left hand side, X over 100 times 68.926 plus 100 minus X over 100 times 70.925. Okay, again, this is coming from the previous slide in case you could not solve the algebra. So I'm going to show you the algebra now. Let me double check whether I copied all the numbers right. It's important that we have the right numbers. Okay, now keep in mind these are the x and 100 minus x's are the percentages of two isotopes. One is x, the other one is 100 minus x. Now, if you multiply both sides by 100, this is what you're going to get. So again, it's simple algebra now that I'm showing you. So multiplying both sides by 100. So if that's the case, then you're going to have 6972 equals to, since I multiplied by 100, there is no 100 at the bottom now. Let's draw a line here so that we clearly see what's happening now. X times 68.926 plus, keep in mind, the bottom 100 is gone now because we multiplied by 100, so that's gone now. So it'd be 100 minus x times 70.925. So let's write down that first. 100 minus x times 70.925. Okay, let me change the color of the pen. Okay, now I can simplify the second part of this problem. 100 minus x times 70.925. That means you are multiplying 100 by 70.925 and also x by 70.925. So what we're going to get now is the following. On the right hand side, again, this is x times 68.926 plus, remember I said that 100 times 70.926, so that's going to be 70925. So 7092.5. Don't forget about that because I multiplied by 100. So that means your decimal point is shifted by 2 places. So that's 100 times 70.925 minus, I have x, this x, and since minus because there's a minus x, minus x times 70.925. Now, in this kind of algebra, you have two quantities with x, this and this. So let's have them on one side, and it doesn't matter which side you select, and I'm selecting the left-hand side. So their sign is going to be changed. So you'd have 70.925x. So it's basically x times 70.925, because I changed it from right side to the left side. Basically, I'm adding the same quantity on both sides. And this is, next term is going to be minus, again, this comes from simple algebra, x times 68.926. And the pure quantities has to be on the other side. In this case, pure quantity is 6972, and I have another quantity coming. This one is 7092.5. Okay, so 7092.5 is 7092.5 minus this quantity, 6972. Now, if you're having some problem with this algebra, I suggest that you get help with simple algebra regarding how to solve for x. So because in Chem 110 there will be other situations where you need to solve for x. So if you forgot this kind of algebra, either follow this, or if you need additional help, I suggest that you get help, math help. This is not chemistry. This part is basically algebra. So now I'm subtracting, and then I'm getting here 1.999 x. So I'm getting x times 1.999, and that's equals to, I have 39, I'm sorry, it's 120.5. 120.5. Now x would be given by, you divide both sides by 1.999, and you get x equals to 60.28. Since this was our percentage, so obviously this answer is directly going to give you percentage. If you use fraction, that means if you don't divide by 100 to begin with, then you get fractional quantity, and your answer would be 0.6028, and then you need to multiply by 100. As solution book, has done that way, but both would give you eventually the same answer. So since x is this, so that's percent of one of the isotopes, first isotope. 100 minus x would be the second isotope. So 100 minus x is going to give you the second isotope, which is 39.72, because 100 minus 60.28. So that's going to give you 100 minus 60.28, and that's equals to 39.72. Now, since we have been using familiar symbol like P1 and P2, then x is going to be the P1 if you can consider it that way. 100 minus x is going to be P2, or percent of isotope 1 and percent of isotope 2. So these are the two answers that we got. Now, of course, if you want, you can round off. So let me change the color of pen and I circle those answers. This is one percentage, this is the second percentage. And I hope you understand this algebra and you try it yourself.